Hello. Till now, we have looked at data analytics using mostly structured data. Let us explore a little bit of text analytics to understand how analytics can be applied on data which is not very well structured, not as well structured as tabular or database data, right? So, what is so special about text analytics? Let us get a brief introduction to language processing to understand why text analytics needs special attention and a different set of methods than the application of statistical methods that we have been looking at so far, right? So, what is really language, right, or natural language, human language as we call it, right? At one level you can say it is just a set of strings over an alphabet. This is how we define a formal language in computer science. A formal language is a set of strings over a known alphabet. You can also say it's the essential characteristic of being human. Only human beings and all human beings have this rich variety of communication mechanisms that we call language, right? So it's a means for human communication. It has naturally evolved. At a philosophical level, it has also been argued in what is known as the Sapir-Whorf hypothesis that language and thought have evolved together. That is, the advanced kinds of thinking that human beings are capable of, the cognitive abilities that they have come because of language, and language and thinking have evolved together in the evolution of mankind. Language is also a cultural identity. We have state boundaries defined based on language in India and Europe, for example, and we fight wars over languages. The statehood boundary is an expression of human creativity, poetry, humor, literature, everything comes out of language. And in fact, even if you believe that some animals, say dolphins and so on, have their own language, they are not quite the same as human languages. There is a famous saying by the philosopher Bertrand Russell, who has said, that no matter how eloquently a dog may bark, it could never tell you that its parents were poor but honest. So the abstract ideas like poverty and honesty and so on are possible. Such constructs are possible in our thoughts only because we have the placeholders for them in language, words like poverty and honesty. Right. So, what is the nature of these languages? As I said, they are naturally evolved. There are a few exceptions like Esperanto and Klingon and so on, but there are also some languages which were created by kings and so on, but most of the languages have evolved naturally. They are very rich in their features as well as variety. For example, if you compare them with programming languages or computer languages of any kind, including HTML and XML and so on, natural languages are much richer in their features and they have a lot more variety. They are very efficient for communication, again in comparison with programming. So, we have to remember this because this is the reason why some of these problems in processing language also arise. The problems arise because they have evolved naturally as efficient means for communication among human beings, right? So, but they are not so good for machines. So, when we try to process text or speech written in these languages, we encounter problems because machines don't have the same capabilities as us. So, at what level should a machine try to process language? If I have a bunch of texts, so something we usually call a repository. So, if I have a repository or a corpus of messages or documents, at what level should I process it? At one level, I can simply treat it as binary data and process it like any other data, right? Should we do that? Then we are not treating it as language at all. We are just treating it as zeros and ones, right? Another level, you can process it as characters, a sequence of Unicode or ASCII or whatever characters. Or you can take two of them, sequences of two of them or three of them, what are known as bigrams and trigrams. You can either do that in terms of characters or tokens. So you can apply your standard tokenizer and separate out tokens, or you can actually refer to a dictionary or a what is called a lexicon or a lexical resource for that particular natural language and actually recognize some of those character sequences as known words, or you can recognize some of them as you know parts of speech, nouns, verbs, proverbs, pronouns, and so on, right? So not proverbs, nouns, verbs, pronouns, and so on, right? Adjectives and adverbs and so on. That is called part of speech tagging, right? You can do that, and this is the level at which most things like search engines are operating today, trying to recognize keywords in the text or in web pages, for example. Or you can go a little further and start recognizing phrases. For example, you can recognize all the names of places, of organizations, universities, companies, people's names, and so on. Or you can break up text into clauses, or you can do analysis at sentence level, which is a basic unit of meaning in most languages. Or you can do it at a larger level in terms of paragraphs, messages, what is called discourse analysis, right? If it is a conversation or even a long piece of text, or you can treat the entire thing as documents and try to classify documents and so on. I'm just trying to illustrate the various possibilities in processing language, and it need not always be in the form of text. So there are a variety of speech-based technologies and applications. They are becoming more popular. They are becoming more commercial now. You have all these personal assistants and that you can buy, and they can answer questions for you. So you have automatic speech recognition, speech synthesis, interactive voice response system (IVRS), voice recognition, speaker recognition, all of those technologies. We are not going to look at speech processing here. Mostly we are only looking at text analytics. So when it comes to text, you can think of parsing using a grammar and a parser, trying to parse the text at sentence level, trying to do some kind of understanding of the text. Or you can simply classify the text using some kind of a classifier, maybe bring in some machine learning and do routing of news articles, and that is how all the news syndications and news aggregators work, right? They give you news articles that are of interest to you. Or you can do basic retrieval, information retrieval, which is popularly called search engines, and you can apply something like PageRank of Google, or you can apply traditional conventional methods. You can try to extract information from documents and use that to answer questions, question answering. Another very popular application is sentiment analysis, where you try and extract the sentiment in that review or that article or that message. Is it positive, is it negative, and then use that for a product or service recommendation system. Or you can actually have a language generation mechanism. If you have a humanoid which needs to answer something, then you probably use the language generation followed by speech synthesis to actually say things to answer a question and so on. Or it could be at an entirely different level where you are dealing with handwritten text. So you have image processing involved in handwriting. So language can be processed at all of these different levels, right? So what are these problems? Are actually they're actually features of natural languages which become problems when we try to get machines to process natural languages. So these languages tend to be very context sensitive, right? I mean it both in a common sense way and as well as in the terms of formal theory of computation. So most programming languages are designed to be as close to a context-free language as possible. But in terms of this grammatical structure, but natural languages tend to have more context-sensitive structures than pure context-free languages, right? They also have irregular constructs, right? There are many exceptions to all the rules of grammar in languages. A few languages are more pure in the sense they have fewer exceptions to the rules of their grammar, and you do need a lot of background knowledge and common sense to understand, to make sense out of what is being said, right? They are heavily context dependent. The sense, the meaning depends on the context of usage, um, and you need that background and that reasoning ability to make sense. There are also varieties of these languages, what are called dialects, local languages, sub-languages, community-specific languages, controlled vocabularies, and so on and so forth. There's a variety of ambiguities and other things called anaphora and so on, ellipsis, anaphora, and so on. Ambiguities can be at structural level, semantic level, multiple meanings for the same word, which is called word sense ambiguity. Variety of non-literal usage, metaphors, speech acts, satire, sarcasm, humor, all of these become relevant at some point if you want the machine to analyze the text and actually behave in manner similar to how humans are able to deal with that, right? Just as an example of irregular constructs, right? So if you give these words and you didn't know their meaning, and then you try to infer the meaning by analyzing what is called the morphology, the internal structure of a word, the inflections of the word, then you could end up in the wrong meaning. For example, longevity does not mean being very long, right, or being very tall. Fortuitous has nothing to do with fort, so it is not about being well protected, right? Bibliography doesn't mean holy geography, and so on and so forth. So polyglot is not more than one glot. Polyglot is in fact one who speaks multiple languages. Homogeneous doesn't mean devoted to home life, the way we all are at present in this coronavirus lockdown, right? That's not the meaning of homogeneous. So you can't really, these are all exceptions, and there are many such exceptions at all levels in language processing, and that's what makes it challenging as well as interesting. So let us see how we can actually apply some of the technologies, methods from natural language processing to do text analytics.